Hi folks, we're going to take a look at number 10 from the Unit 6 assignment. So here they tell us that the height of a triangle is three times its base, and they're telling us that the base is increasing at a constant rate of 4 centimeters per, I believe it's seconds. All right, and then they want us to find a formula for the area with respect to time. All right, so here we're talking about a triangle, and of course we should know that a triangle is given, or the area of the triangle is given by its base and its height, okay? Except here they tell us that the height is equal to 3 times the base. So in other words, this is all going to be dependent on one variable. So the area here is now going to be just a function of the length of the base, because it's base, b, times height, which we know is 3b, divided by 2. Okay, so in other words, we can write this as 3 over 2b squared. All right? But they want us to determine a function for the area with respect to time. The reason why we can do that is that the base itself is a function which depends on time. All right, so this is where we're going to have to determine how is base dependent on time. So first of all, they tell us that it's growing at a constant rate, okay, of 4 centimeters per second. So that means that we can represent it with a linear function. Okay, we know that the slope is going to be equal to 4, so it's going to be positive. Now, the one thing that they're not specific about is, does this triangle have an initial base? All right, so this is where we have a little bit of leeway to determine this function here. So you could decide that the triangle starts at a base of 1 centimeter, say, and then from there it's increasing at 4 centimeters per second. Okay, what I'm going to do, just to make it easy, I'm going to assume that we're starting at 0. So in other words, you know, this triangle just spontaneously appears and the base starts to grow at 4 centimeters per second. So in that case there, the base with respect to time is just going to be equal to 4t. Okay, so times 0, the areas would just be 0 because the base is equal to 0, and then it starts growing over time. All right, but if you had done this as 1 plus 4t and just specified that, hey, the base of the triangle, I'm going to assume starts at 1 centimeter, that would have been perfectly acceptable because they didn't specify it in the question. So it gives me, like I said, a little bit of leeway. So now what I'm going to be finding is the area, which is a function of b, and b is a function of t. In other words, this is just a composite function. So here we had the area with respect to b was 3 over 2 b squared, and of course b is given by 4t. So make sure you put that in brackets because the whole thing is being squared. And now from there I can simplify this. So 3 over 2 times 16t squared, and 16 and 2 simplify to 8. 3 times 8 is 24. So 24t squared. Whoops, t squared. So now if I want to find the area at any particular time value, I don't have to first find the base and then from there plug it in to find the area. I can plug my number in straight into this function for area directly with respect to time. All right, so just to recap here, step 1 was to realize that I could write area in terms of the variable b, which represents the base. The height didn't need to come into play, or it came into play, but it depended on b. All right, then from there, I figured out that I could write the length of the base with respect to time, and then from there, I used the composite function to write area directly with respect to time. Okay, that's it for this one.